Hi everybody, my name is Reza and I am a PhD candidate in SVV group directed by Leon Lebriand at the University of Luxembourg. In this video I am going to present a tutorial about CoCoTest or Continuous Controller Tester, a tool for automated model-in-the-loop testing of continuous controllers. CoCoTest takes the MATLAB Simulink model of a continuous controller as input, and for each controller requirement generates one heat map diagram and a list of worst-case test scenarios. All the information related to testing a model, including the test configurations and the test results, are encapsulated in a test workspace. Each test workspace has a unique name and is stored on the permanent storage. CoCoTest provides users with a wizard to create a new test workspace. At the first step of the wizard, user identifies the workspace name and the type of the function they are going to test. Currently, CoCoTest only supports testing continuous controllers. At the second step, the user needs to identify file paths required for running the controller model. This includes the MATLAB executable file, the Simulink model of the controller under test, and several other paths. At the next step, the user has to identify the names and the ranges of the desired value and the actual value variables, and also the model simulation time. Before starting the test case generation, user should run the model with at least one input signal and check and confirm that everything is fine with the provided information. Finally, the user has to identify the test configurations. This includes the configurations of the heat map diagrams, the controller requirements that have to be tested for the controller under test, and the number of the worst-case test scenarios that have to be reported by CoCoTest. Based on the test configurations, CoCoTest estimates the running time of the test. Moreover, the user can also identify the critical operating regions of the controller. If user identifies such regions, CoCoTest looks for worst-case test scenarios only within these regions. User can select either the regions that are critical or the regions that are not critical by clicking on them, or alternatively by using sliders. Pushing the Start button runs MATLAB and starts test case generation. The progress bars indicate the progress of the test generation. As soon as the test generation finishes, the results form appears. Several useful functions are implemented in the results form, including viewing the heat maps, running worst-case test scenarios, and running any arbitrary test case. We evaluated CoCoTest by applying it to two case studies: a publicly available case study, which is a simple PID controller controlling a DC motor model, and a complex industrial case study from automotive domain. Here I go through the results from the second case study: Supercharger Bypass Position Controller, or SBPC, which controls the position of a flap that adjusts the air pressure supplied to the engine. 5 heat map diagrams and 5 worst-case test scenarios were computed for different controller requirements by CoCoTest. For example, running the worst-case test scenario for smoothness requirement results in a test scenario with 20% undershoot. The engineers from our industry partner found these results very interesting, as the worst-case test scenario previously found by manual testing had a 5% undershoot. To further evaluate the usefulness of our approach, we created 3 mutations of the SBPC model by injecting one fault in each mutation, for example by changing a Simulink sum block to a Simulink minus block. For all these 3 models, our approach was able to find test scenarios that violate one or more controller requirements. For example, for the first faulty model, CoCoTest found a worst-case test scenario for a stability requirement, which obviously violates the stability requirement. As you can see, most of the heat map is covered by white regions, which means that it is very unlikely that someone could find this worst-case test scenario by manual testing. This wraps up this tutorial video. To find a more complete version of this video, please go to sites.google.com/site/CoCoTest tool. Thank you very much for your attention.